Yes, let us start. Okay, we are going to start about simple harmonic motion and oscillations. First thing first, I will just talk about one. Whenever you have to talk about object attached to the spring or simple pendulum, we call that their motion is periodic. Why we call it periodic? Because it is repeated itself in a particular interval of time. For example, this is a mass attached to string. What we call it? We name it simple pendulum. If you pull this simple pendulum to this side and you leave it, what will happen? It will go back to its initial position, then it will move forward because of inertia and return back, and it will continue this motion forward and backward. We call it is periodic motion, it is oscillatory motion, or it is repeated motion. Similarly, if you have a mass attached with a spring, this is initially the position of a spring, and this spring is here. If you attach a mass, what will happen? This mass will make it extended to some new position. When you attach this mass and release it, what will happen? If you pull it down and then release it, it will go down and then move up and down again and again, and it will continue its motion up and down, and it will be repeated. We call it periodic motion. So any motion that repeat itself in a fixed time, we call it periodic motion. I'm repeating my word, motion that is to and fro. To and fro, I can use the word, I can say forward and backward. And it repeats itself forward and backward, up and down, to and fro, all are the same word. Motion that is to and fro, forward and backward, up and down, and repeats itself. We call it repeats itself. We call it, we call this one as repeat itself. We call it, we say it is periodic motion. And as it is moving up and down, forward and backward, we can also say oscillatory, periodic or oscillatory. Why oscillatory? Because when it goes a complete rotation, we say it oscillation. So this motion is oscillatory motion, or you can also say it vibratory motion. Now, second thing is very important that whenever we talk about oscillatory motion, we need to talk about a law that is called Hooke's law. According to Hooke's law, when you apply an extension, when you apply a force on the object, this force is directly proportional to the extension. Force is directly proportional to the extension, and we can say F is proportional to minus X because it is always opposite to the restoring force that make it tend to move toward the center. Again, back to the original position. So mathematically, we say that Hooke's law F is equal to negative kx, and if we say that spring is coming back to its initial position by a force, that force is called restoring force. So restoring force is equal but opposite to the applied force. So restoring force will be equal to F is equal to kx. So we just need to have the same value but opposite in direction. Here F is the applied force, X is the displacement, and K is the spring constant. We have all of these things to talk about. That what is unit of the displacement? Unit of the displacement is, now here say that what is F? We say that F is equal to Kx, and we can just simply find the value of K here. When you are talking about K is named as spring stiffness. And spring stiffness is equal to what? Spring stiffness is a constant. And for any constant, negative sign is not important. Constant is just a number. Negative is for the directions. So K, whenever you are finding from this equation, you can say it is F over X. So unit is force for the Newton, and for the displacement it is meter. So you can simply say that Newton per meter is the unit of the spring constant. And its definition is, as this fraction is called the ratio, so you can say ratio of applied force to the extension. X is here applied force to displacement, or you can use the word extension here. So whenever we are going to find K, what you need? You need to divide force by the displacement. Normally displacement is in the centimeter. We will convert it to meter by dividing it by 100. Now, if like this spring is hanging, for hanging spring, what would be K? For hanging spring, if spring is hanging, what you will do for hanging spring, you will say K is equal to force changes to weight mg over x. So this is the same way, but you will do it as mg over x because this is your weight is converted into force. Let's see for a simple example. If you have this example in the next page, you have a car in which people with mass of 200 kg are stepping into. The actual mass was 1200 kilogram, but you increase the mass. So the shock absorber is going down because of the external weight. So the mass you are attached here is 200 kilogram. That is being going to extension, give the extension to spring up to 3 centimeter, and x is equal to 3 centimeter. I will change into meter by dividing it to 100. So this 0.03 meter when I divide by 100. Now you are asked to find the spring constant. Yes, please. Yes, the same thing I will do here for finding K. I will not use F over X. I will use mg over X. So when I will do mg over X, so you have mass and gravity near the earth, you have 9.8. So this is 200 times 9.8 over X. Can you hold the calculator, any one of you, please? So this one will be the value of K, and the K can easily be found. It would be approximately 65,000.
We were going 6.5.
65,000.
Oh, yeah.
65,000.
6.5 times 10 to the power of 4.
6.5 times 10 to the power of 4, and unit is Newton per meter. In the next part, what it is saying, if there are people with more mass like 300 kilogram rather than 200, so K, because spring constant remains same, it is the same 6.53 into 10 to the power 4, and now the mass changes to 300 kg. So you are asked to find how much it will be lowered. You have to find X. So this one, I will use the triangle method. You know, Hooke law is F is equal to K times X. So F here is K times X. So if you need X, so you will say X is equal to F over K. Now here F is what? F is mg. The same thing because it is load, spring is hanging. So K is, you have the value 6.5 into 10 to the power 4. So when you substitute the values, 300 times 9.8 over 6.53 into 10 to the power 4. So your answer will be approximately, I think, 4.5 centimeters, if I'm not wrong. So this will be 4.5 centimeter or 0.045 meter. Okay, this is one example. I can ask you different type of question related to this, and I'm telling you that most of the questions are related to this, most of it. So what you will do, for example, if I ask you if you have a mass attached to spring horizontally and you apply a force of 50 Newton and it extends up to 2.5 centimeters. So how much is the spring constant? What you will do? Yes, please. You know the triangle hook law. F is equal to kx. So here you will, this is division and this is multiplication. So k is equal to what? F over x. So F is 50 divided by 2.5 by 100. Why I divide by 100? To convert it into meters. So this is 2000 Newton per meter. This is 2000 Newton per meter. Let me give another question. If I ask you that you have a mass attached to the spring and that has the spring constant of 300 Newton per meter and it extends up to 3 centimeter. How much is the load attached to that one? You are asked to find force. So what you will do? This is force is also called load when it is hanging. F is equal to K times X. So when F is equal to K times X, what's the answer? Yes, so you will have F is equal to 300 times 3 over 100. So this is 9 Newton. If I'm not wrong, can you please check it out? Okay, this is the first part of the lesson that is ended. Second part of the lesson has many smaller definitions. What kind of definitions? First, we need to talk about one thing. When you have a mass attached to spring, you need to know this figure that I am going to draw. What is that figure? You have a mass horizontally attached to the spring. It has three positions. What are those three positions? One is equilibrium, extreme, and the other is also extreme. For example, this is the position of mass attached with spring in the middle. This is x is equal to 0. Why I write x is equal to 0 with equilibrium position? Because the displacement from the equilibrium position to the equilibrium is 0. Okay. The other position you can say is extreme position, and we can say x is equal to plus a. Why it is called x is equal to plus a? Because this is the position when the displacement is maximum, and maximum displacement is called amplitude. Maximum displacement is called amplitude, and it is to the right we put it positive amplitude, and when it is to the left we put it negative amplitude. So this is also called extreme position. So we have the name of these positions, extreme and mean. Now, if you have this, a spring is attached and it is moving throughout the journey from positive toward negative, what do we have here? We have, first of all, when this spring will go to the right, it will stop for movement. When it will stop for movement, its velocity will be 0. When it will move from the equilibrium position, it will move faster and velocity will be considered as maximum. When velocity is considered as maximum, we can say that it is whatever the value is, it will always be maximum. And here, velocity is 0. Velocity is maximum and velocity is 0. I cannot write maximum here. Okay. Now, when velocity is 0 and maximum, what about kinetic energy here? Kinetic energy. Kinetic energy when velocity is 0, you know kinetic energy is half mv square.
Velocity max, so potential energy is 0.
I am saying kinetic energy.
Mr. Kinetic max here.
And here kinetic is
0.
0 again, because kinetic energy behaves like the velocity. So kinetic energy is 0 on the extreme and it will be max in the equilibrium position. So this will be the behavior of kinetic energy. And when we talk about potential energy, it behaves like the acceleration. First of all, we need to talk about what acceleration and how acceleration is. Because in the middle, velocity is always same maximum. So you will say acceleration is maximum here. And maximum acceleration is, I always not able to write m here. I don't know. It's a problem with my maximum. And when acceleration is maximum, I just make a little bit mistake and you guys didn't notice.
0.
Because always, all the time, it will have the same constant velocity. So you can say acceleration is 0 here. And extreme position, it will be maximum, acceleration maximum and acceleration maximum. And potential energy behaves in the similar way. Potential energy max at the extreme positions and potential energy 0 at the equilibrium position. Here I would like to mention few important relations with that one that is important. When I say velocity, so velocity is generally calculated by the equation V is equal to radical K over M a square minus x square. As it is radical, you can have plus minus. This is the velocity at any position. Any position mean except extreme and equilibrium position. Velocity is maximum. Where? Where velocity is maximum at equilibrium position.
Yes.
So the equation for this is V max and it is K over M radical a square only without x square. When you are talking about acceleration, generally it is equal to k over m times x. When it is maximum acceleration, then it is k over m times a. So it is similar to the velocity maximum, only radical sign and square sign is missing. Now come to the other point. When you talk about energies, the first the first thing about the energy here, the total energy is equal to sum of kinetic energy plus potential energy. And always this total energy is equal to half Ka square. So wherever you are, the total energy here is at extreme position, at a minimum position, at other extreme position, half Ka square, half Ka square, half Ka square. Now listen carefully. This is very important point. If kinetic energy is 0 at extreme position, the total energy is potential. This is total energy is equal to potential. How much? Half Ka square. Here total energy is only potential, half kinetic energy, half Ka square. And here in the middle, total energy is kinetic because it is half Ka square. So you have to remember for the total energy, half Ka square always, all the time. This is acceleration, normally K over M time X. Acceleration, general acceleration is K over M times X. But when it is maximum, K over M times A.
Rewrite it.
X
Yeah, let's rewrite it also. It
doesn't look X.
It's
Okay, this is X now. Happy?
sure.
I cannot move it. I will write it here. K over M times X. Okay. Now here, this question is easy for you. You know that when you are asked anywhere acceleration of the mass is zero. So you know acceleration is zero where? At x is equal to plus a and x is equal to minus a. But very, very important thing about acceleration, you have to remember acceleration is always toward equilibrium position, toward x is equal to 0, and always negative. Wherever the position is, it is negative, and acceleration is proportional to negative x. That's why I wrote. If more extension, extreme position acceleration maximum, it means distance is more. Mean position acceleration is zero because displacement is zero. That's why proportional to x. And negative sign is because it is always toward the equilibrium. That's why it is negative. So when I will ask what is acceleration at x is equal to plus a, maximum negative. X is equal to minus a, maximum negative.
And it's negative x because of the direction.
Because of the direction. Okay, this one is the more generalized form. Here we didn't talk about frequency and the period. You know that period is what? Period is time to complete one vibration. T is equal to time over number of oscillation. Yes, please.
It's not because of the direction. It's because it's going to the equilibrium. It's
Yes.
decreasing.
So frequency is what? Wissam, what is frequency? Frequency, one relation is 1 over t because it is reciprocal of the period. You can say number of oscillations over the time. So in this question, if you have a frequency of 1.25, if I ask you what is the period, so you will just say t is equal to 1 over f, and it will be 1 over 1.25. What is the answer? 1 over 1.25. It is 0.8 second is the period of one oscillation. But in this question, they are asking 100 oscillation. So if period is 0.8, then for 100 oscillation, what you will do? For 100, 0.8 times 100, that is 80 second. So this will be 80 second C. Now, one thing I didn't discuss here, what is one oscillation? One oscillation is a complete round trip. For example, if these are the positions, I am just trying to repeat again these position. This is equilibrium position. Please keep focusing on the time. What is the time? X is equal to minus a. How much is the time left? 15 minutes. X is equal to minus a and x is equal to plus a. Now, what is one oscillation? One oscillation is if you start from positive A, you go to negative A and then back to positive A. If you start from negative A, you go to positive A and then return back to negative. If you start from 0, go to positive A, go to negative A and then get back to 0. So this is called one oscillation. All of these are the ways to describe one oscillation or one vibration. Now it comes to what is simple harmonic motion. Simple harmonic motion or SHM. What is simple harmonic motion? We call it SHM. It has three conditions. Number one, obeys Hooke's law. Number two, it is periodic. It is repeating and again. And third and very important, acceleration is always toward equilibrium position and is always negative, is proportional to minus x. Yes, please. This is both are ended. Finish everything. Okay. Now, if you look at this figure, they are saying, suppose in the figures, you stretch to double. What happened to the energy of the system? Energy of the system is total energy. You said that half Ka square. Agreed? So if amplitude is doubled, what will happen to the total energy? Total energy will become A changes to 2 mean 4 times. Total energy will increase to 4 times because A is changing to 2, 2 square is 4. They are saying maximum velocity. Part B, maximum velocity. What is the equation? K over M radical into A square. I can write it like that. I can also write K over M in the radical into A. So if you double, it means V max is double. Yes, Ayman?
No, it's not.
V max will be doubled. They are just asking, you are changing to amplitude. Look here. A changes to 2. So total answer will multiply it with 2. A changes to 2. Total answer is multiplied to 4 because it is 2 square. And last thing, acceleration is the same. Acceleration is what? It is K over M times A. So if you double the A max is also doubled. So what are the answers for this? A max is doubled, V max is doubled, but total energy is 4 times. A max is doubled. What was first? First you put 1 and then you put 2.
Yeah.
Check the answer difference. First put 1 in this one.
1?
1, yes. What is the answer? Okay, now put 2 and get the answer. You got my point? First A is 1. Now you double. So both difference of answer I was trying to tell. Okay, now this is the one question that will give you whole scenario. The first one, you have a spring that is stretched to 0.15 meter when the mass of 0.3 kilogram is suspended. So you have this one and it is initially here. When you suspend the 0.3 kilogram, it's suspended to this distance and this is 0.15. So first of all, you are finding K is equal to mg over x. M is 0.3, G is 9.8 and X is 0.15 and it is meter, so you don't need to convert. So what is K here?
6.
Can you please recheck again? I think 19.6. So K is 19.6 Newton per meter. Now they are saying the same spring is now moved to horizontal. The spring is now moved to horizontal, and when it is moving to horizontal, they extend it to some new position. So here extension is 0.1 meter. So this 0.1 meter is actually amplitude because you move it to maximum level 0.1. So first question is asking about amplitude, part B. So amplitude is 0.100 meter. Third part, they are saying magnitude of the maximum velocity. Yes, please.
At the beginning, it says the string stretches 0.150.
Yes, they are hanging at that time to find K.
K equals 0.1.
No, 0.1 is the displacement.
So why is it amplitude?
0.15.
How did I know?
Because you pull it up to 0.1 and then you release it, will it go further backward? So that's the maximum it can be. In the first part, it was hanging and you pull it 0.15 to find K. The second part, it's horizontal now. Horizontally, it cannot extend more. So the maximum extension is 0.1.
Yeah, but how do I know it's going to extend more?
How you cannot know it cannot extend? You pull a spring, it's horizontal. You pull a spring, it's horizontal. You pull it and release it. What will happen? It will go back to equilibrium position or go further to extreme. That's it. And when it return, it's for sure it will not go beyond that point.
So only when they mention that it's not max, right? When it's not a max extension, but then I consider it to be X.
No, it is understood. Whenever you pull horizontally, the maximum displacement is first time. After that, it will slow because of friction or something else. So it cannot go back.
We decide what's max.
It is understood.
The stretch, like if I stretch this to 0.2, I will consider
That is
as
amplitude.
max. And if I stretch it to 0.3, then that will be the new one.
Yes. Yeah. Okay, now Vmax, how you will find? It is
in vertical position, it will be they will tell us it's max or not.
automatically it will be max because whatever you pull, whatever the load, it cannot extend. So Vmax is K over M times A square. So can you just substitute the values 19.6 over 0.3 times 0.1 squared? What's the answer, please? Yes.
How do I know if it's X or K in the beginning? You have meter something.
What is K? Newton per meter. What is X? Meter or centimeter? So it's a simple, it's a distance, and K is force over distance. How can you mix up?
But K itself, it's spring constant.
Yes, it is constant. It is force over displacement. K is measured in Newton per meter, not in meters only. Okay. Next part is you have to find the velocity if mass is half an the equilibrium position, half a distance from the mean to extreme. So V is how much? This is K over M into A square minus X square. What was the answer of previous one? Sorry. V max was
0.8.
19.6 over 0.3 times 0.1 square. 0.81. 0.808 meter per second. And maximum. So here what you will do, same 19.6 over 0.3 into 0.1 square minus 0.05 square. Take a square root. What's the answer, please? Just tell me the answer. 0.700 meter per second. Okay. Now if the same question asks you to find acceleration maximum, A max is equal to K over M times A. 19.6 over 0.3 times 0.1. This is 6.53 meter per square second. Ayman, if you are asked to find total energy, half K A square. What is half K A square? Half into 19.6 into 0.1.
One. Yeah.
Yeah. So total energy is
0.9.
0.98 joules. Joules. Okay. If you are asked to find in the middle,
Is velocity max, acceleration zero.
so total energy in the middle will be kinetic energy,
Yes, sorry.
and in the extreme position it will be potential energy. If it is in between somewhere here somewhere, so at 0.5 meter distance, then what you will do? Half mv square. To find kinetic, first you will find kinetic with half mv square, and then you will use that kinetic energy to find the total energy. So this is, yeah, then you can know if in the middle, not extreme, not mean, in between mean and extreme, then you can do it by this way. Okay, thank you so much.